Okay, so now I want to discuss the effect of continuous maps on these sets pi0 that we've been thinking about. So, so let's let f from x to y a continuous map. So of course x and y are supposed to be topological spaces here. So the first lemma suppose we've got 2 points in x, and suppose that they're related according to this relation that we've been considering. So there's a path in x, a continuous path in x from A to B. So then I want to claim that f of A is related to f of B in y. And the proof is straightforward. So what does it mean to say that A twiddle B? That means that there exists continuous U from the interval 0, 1 to x with U of 0 is A and U of 1 is B. And let's put V is f composed with U. So that's a continuous map from 0 to 1 to y. Then what's V of naught? That's f of U of naught, f of A. And V of 1 is f of U of 1, which is f of B. So that's a path from f of A to f of B in y as required. So as a corollary of that, we get a well-defined map, which I'm going to call f lower star, from pi0x to pi0y, with f lower star of square bracket A is equal to square bracket f of A for all in A and x. And a couple of properties of this. Firstly, a very trivial property that if we take the identity on x and do this kind of star operation to it, and that's just the identity again. And then just tiny bit less trivial. If we've got continuous maps like this, f from x to y and g from y to z, then there's kind of two ways we can go from pi0x to pi0z. One way we can do it is we can do this g star and compose it with f star. The other way around is that we can do the composition first and then do the starring operation. Okay, so that's our claim here. So we've got the kind of recipe which sort of specifies what f lower star is supposed to do. It's supposed to send square bracket a to square bracket f of a. But the potential problem with this is, what if square bracket a is the same as square bracket a prime? Okay, then f lower star a should be equal to f square bracket f of a because of the first thing, but f lower star of this should also be the same as f lower star of square bracket a prime, which is square bracket f of a prime. I'm sorry, I'm writing too high here. Okay, so let's call this thing C. So if we've got this C, which is a path component, and if suppose it's equal to square bracket A, and it's also equal to square bracket A prime. Okay, so we've got kind of two different answers for what f lower star C should be. But if square bracket A is equal to square bracket A prime, that's the same as saying that A is related to A prime. Therefore, f of A is related to f of A prime by the lemma that we just proved. Therefore, square bracket f of A is equal to square bracket f of A prime in pi 0 y. Okay. So this rule that we wrote down here, f lower star square bracket A is square bracket f of A, so this gives a well-defined function. Okay, so we've got so that's kind of the key point, that this function is well defined by this rule here, that f lower star square bracket A should be square bracket f of A. Now let's not bother with part A, let's just look at claim B here. Then what have we got? Well, you get, we can look at G-link composed of f lower star applied to some A, say, to some square bracket A. Well, that's the same as G composed with f applied to A in square brackets. Let's just maybe annotate that a bit. So this is just the then this is G of f of A in square brackets. That's just the definition of G composed with f, which is G lower star of square bracket f of A by definition of G lower star, which is G lower star of f lower star of square bracket A. and that's the same as G lower star composed with F lower star of square bracket A. Okay. And so we see that G composed with F lower star is equal to G lower star composed with F lower star. Okay, so that was the claim about composition. And also, id star square bracket A is square bracket id A, which is square bracket A. So id lower star is the same as id. So that's what we need to say about these induced maps F lower star. In a later video, we'll explain how this fits into the context of category theory, definition of categories and functors.